The next big thing we're going to look at here is the idea of a set complement, or the complement of a set, where essentially the complement of a set will consist of everything other than that set. So thinking back to our example from the states, if we have that A is the set of states beginning with the letter A, like we said, and U is the set of all states, then a complement, which we denote A prime, would be the set of all other states, the states that do not begin with the letter A. The 46 states, California, Colorado, Connecticut, Delaware, Florida, Georgia, Hawaii, and so on down the line, because you don't want to see me list 46 states badly. It wouldn't be very exciting for anyone, least of all me. So let's not do that. But get the idea there that when we're talking about a set complement, we're talking about the things that are not in A, but that are in U, like we have here with our set builder notation, that A prime is going to be the set X of things such that X is in U, but not in A, where the idea of a complement is very, very much dependent on the context. It's very much dependent on the universal set. Without a universal set, the idea of a complement is meaningless. It's entirely undefined, where, again, those of you who have some familiarity with statistics might remember that in other contexts, for stats, talking about discrete things, we might talk about that as being a bar. And is that very similar? Yeah, it actually is. And we're going to see that again near the end of this semester, but just know that if you do have some of that stats background, you'll have seen a lot of these things before, and if you don't worry about it, but you'll probably end up taking stats, so hey, use a preview. I guess it works out for everybody in some sense. Anyway, now that we have a brief idea of what a complement is, let's actually take a couple of examples, because it's a lot easier to understand complements with that concreteness than to just get the definition. So for our first example, we're going to use the previous examples of sets A, B, and U, and we want to find B complement. So if we want to find B complement, or as some might read that, B prime, basically what we're going to do is take the set B that we have down there and look at everything else in the universal set. So since B there is D and E, and the universal set is the alphabet in lowercase from A to G, B complement is going to be A, B, C, not D, not E, so F and G, not a J. That's a comma. That'd be something though if I threw that one in there too, but it's not included in the universal set, so we're not going to include it in our complement. Again, the complement is very much determined by the universal set, as is the set of everything else in there. If I talked about the entire alphabet, then that would be the 24 letters other than D and E, but here we only care about the first 7 of them. So we only get that 5. Anyway, let's get one more example here to keep developing this idea. For this, we have the universal set 2, 4, 6, 8, 10, along with the set A is 2, 4, 6, and we want to find a complement. Again, for finding a complement, we're just finding the things that are not where we're starting. So we have that A is 2, 4, 6, and U is the even numbers up to 10. So that's just going to be, for our complement, 8 and 10. Again, with these small sets, I keep saying again, but with these small sets, there's not a whole lot to it. You just see what's in there, see what's not in there, take what's not in there. The complement is a very, very straightforward term that's much easier to see in the context of specific universal and single sets. Hopefully you get the idea. Where the next thing we can talk about here is developing a little bit more about what we mean when we say and. Because we have a special way of talking about the idea of and with sets through a thing called the intersection.